Testing 1, 2. Okay, well, welcome to this special episode, as it were. So the question is, if we have a very large board with just two edges, and the black king is, let's say, n horizontally from this edge, then the white king is immediately opposite of it. There's just one square in between, empty square. And the rook is diagonally from that, so like in this position. Then we call n is equal to the number of empty columns, so there's 1, 2, 3, 4 here. And m is the number of rows that the black king has. So in this case, m equals 1. So it's stayed here. And then let's say they're all at the end. So here's a case with m is 2 and n is 4. Same thing, and yeah, the rook is over here instead of, or it cannot be here in this case, but I don't have any ms3 case. Yeah, here's an ms3 case, but the king is, well, not where it should be. Okay, let's code this. The textures work, by the way, so because it was something else. The code already worked. I'm just gonna kill everything, I think. Okay, there's something wrong with YouTube. It says excellent connection, but I don't have I don't have a picture or something. An error occurred. Please try again later. What the F is this? No, now it worked. Okay, so in this case, I think I can switch to YouTube, so a bit larger font. Now, of course, we are going to write classes. Let's start with the king. Maybe all of them are pieces, so let's start with a piece. So you have a class piece. And each piece has a coordinate, 2 coordinates. Well, let's call these n and m. Though maybe I should call them x and y, because if you look at the picture here, then well, yeah. Well, you can do that. I mean, the number of empty columns here are 4. And then I want the black king to be at coordinate 4, which is possible if we just start at 0. So this is 0, 1, 2, 3, 4. So with the king on n equals 4, n is indeed 4. And with the white king then on m equals 1, then m equals 1. So it depends on the color of the king, but then it corresponds kind of to n and m are not super bad. So this then is the coordinate. Let's say call it the horizontal. Of course, it doesn't make any difference. You can swap horizontal and vertical, but okay, whatever. Horizontal distance to the left edge. Zero means against the edge. And then this is the vertical distance to the top edge. 0 means against the edge. So 0, 0 means in the corner. Just add that as well. I don't think there's much more about a piece. Well, both the rook and the king can move either horizontally or vertically, but I mean, the king can only make one step, so I could add here something like maybe a boolean, which then just basically says that it is the king or the rook. Yeah, we're going to derive from piece, so nah. But yeah, on the other hand, I'm on. If I added boolean here, then we have everything in one struct. Otherwise, if I ever end up with a base class pointer to the piece and I want to do a move, then well, that has to be a virtual function. I'm not sure if that is. I probably should just treat it as a struct, and then it's hardly a piece really. It's just the position. The position of a piece. And it is a header, so we need some guard. I'm not going to give it a constructor because we can just use a bracket initialization. Okay then, next we do the king. You can, I mean, I could do like position now, of course. Because, yeah. I'm not sure it makes any sense really to derive from position, because that would mean that we have an function at the very least that then takes a piece as argument or a reference to a piece probably, and then doesn't really care about if it is a king or a rook. That doesn't exist. If you ask me, it always matters. For example, the distance to the corner, as I talked about in the description of the video. So see below the video. They're completely different beasts. The position of the black king is even different than the position of the white king, and so on. So let's just do it like this for now then. And I'm gonna abbreviate it even because I feel going to have to type it a lot. And then we need to know the color, I suppose. It's yeah, color. I mean, why use a boolean? I'm going to use color because that gives more flexibility. So make that a wrapper around the boolean then. And that's about it, right? I mean, a king. Well, no, yeah, that's the only thing that the king is made up of. The position and the color. Well, okay, let's write the color first then, next. Well, I could use a boolean, of course, but then you have to type true and false all the time, which is very confusing. So let's just use an enum. Maybe I should use. I mean, this is going to be a wrapper around an enum. Then that's kind of silly. Do I need member functions for the color? Sort of, maybe, but then you might as well use free functions. So not member functions, but functions that are just global, which get the color passed. You know, if your member function is basically also a free function, but then you have to pass automatically this pointer to the class itself is being passed as an argument, and of course it has access to the private members. Maybe in this case you're just going to use an enum. Not even an enum class. You can just stop white and black, black and white. I think that will do fine. Note that we are going to pretend that, well, white is the one with the rook. So for the rook, I don't need a color. It's just always a white rook. White rabbit. So this thing only has a position. And then, as always, I mean, we probably need some debugging. So that means that I really want to be able to write every object of any type to an O stream, you know, to get an idea what the hell that the value is at that point. So if I write a rook to an O stream, then the only thing that we can print is, of course, the the position, but maybe just add the fact that it is the position over rook as well. Yeah, normally I use all kinds of fancy stuff of my toolkit, basically, utils, but in this case I'll just throw it to full independently of anything. So we're going to need an operator less than for an O stream that we can pass a rook. And that thing then needs access to the position, which so far I have hidden because it's private, because it is a class. I'm not sure if that's going to be very helpful in this case. But yeah, I mean, I don't see a reason to make my members public, because usually you really don't want to do that. So let's see how much typing work it's going to be. Let's keep it private. But yeah, this thing must of course have access to that, and we probably need access to it as well. So I always like to explicitly type that this is private, even though it's by default already private. And then we'll add the public accessor for the thing. And position is very small. Might as well pass it back by value, but well. So it's a class, you know, like we pretend at the moment that we don't really know what, how big it is, as it were. Let's just do normal, and then oh yeah, keep it. Do I keep pos? Using pos for position is I really hate abbreviations, but I think pos is very often used. So, well, so obviously const, it doesn't change the class, so we can just return pos. And then having that accessor, the accessor can simply be used by this operator, which I'm not going to define in the header, because yeah. So let's create a .cxx file for the rook, which then defines seriously. Okay, so now I want to print the content of the rook. And the content is just the position. Probably I'm not going to use this very much, because the rook is going to be part of the board object, and if I want to print a board, then I think I'm going to prefer a visual representation than just print the coordinates. Well, I don't know. Let's do something, because you know, if it irritates me at some point, we can easily change it, of course. So we're going to say rook and then just print the position or something. No new line. The new line is printed by whoever is calling this. What is this? Something went wrong. Okay. Create a .cpp file. I'm going to use CXX. Yeah, we also need to be able to print the other piece, the king. So it's probably very much the same thing, except now it is the king that you want to print. And of course we need accessor as well for, well, the position, but also for the color. So put a color up front row. Means it's going to be the white king or black king. Or do you think that's a bit too much? Too long, I mean, the string. Could abbreviate that as just a K and an R. And like I did here, put a B in front of it for the black king and a W for the king, a bit shorter. I don't know yet. And then of course the color must be, we must be able to print the color as well, because this is now type color, and that then must print white or black. Oh, this must be a king. Feels like a bit silly. I just worked on utility to print any enum automatically, but yeah, then I have to clone my Git submodule again, and I just said I wouldn't do that for this one. Yeah, this really has to go by value, right? Oops. What am I doing? Right. Now OStream and etc. is not, well, we need a header for that. So we're not really using it here. We can work with the it's just a reference, so we can use a forward declaration, which is defined in iOS forward, which should compile a tiny little bit faster. Wait a minute, why am I confused? This has a piece.h. Yeah, there's no piece, there's a position. I need a position and the color, of course, and then, oh yeah, the color just has nothing, it's just the color. But the hook has a, yeah, that's missing. I thought there was some kind of asymmetry there. Yeah, now we only have it forward declared, so in order to actually use the OStream, you still need to include the whole thing when compiling the CXX files. Okay, the printed, damn it. Now, next is we need a board, of course. Now, our board always has 2 kings and 1 rook. So we don't need a vector or something fancy. It's just like literally. Oh, we have a king. It's the white king. I'm gonna really call it like that. We have a black king. The black king is more important, actually. And this way I can also keep my white rook close to the white king. Now yeah, you're gonna say it's kind of silly to put a W here because it's always white, but yeah, well. That's what I did here as well. It makes sense, I think. And most likely we want accessors. I mean, you can almost always add accessors without any penalty or problem. As long as they are const, of course. You don't want to add random... I mean, you don't want to make them public, so you don't want to add member functions that can individually change everything. Then you might as well make it public. Well, not even. I mean, even then it's better to do it through some kind of member function. So let's say you have a program and you have no idea who or what is changing your black king position. Then if it is public, then you really don't have any idea. And if the change to it must go through a certain member function, then that is the point where you can add, say, a debug output, for example, or a breakpoint. So it still gives a lot more control. But accessors, yeah, I mean, if anyone, any part of the code is happy with reading mean, in a multi-threaded program, that's different, but this is not going to be multi-threaded. So just add accessor for everything, and I'll call it blacking, and it's const, obviously. And this returns the black king object, yeah, as a reference. And then the same thing for the white king. And we have a rook object. Yeah, and then the harder part, we're going to want to be able to print this as well. The format of which is not very clear. Plus, printing to an O stream is virtually always debug output. And you don't want to have new lines in that. So we should print it for the debug purpose, everything on one line. While, of course, I want to inspect the board as a human. I want to see a part of the board. So maybe I should not use an OStream in here. That is, I think I'm going to add the OStream operator. But indeed, just to print, something, to actually have the values of the board at that point in a log or something. So I can think about it if something goes wrong. But you also need a member function that is not really for debug output then, but that actually prints to, say, standard out. And that can print new lines then. So this is going to be the debug output function. And we're also going to have call it printer. Yeah, no, I'm inclined to say print on and then let you print it to anything you want. Yeah, maybe to a file or something. Yeah, let's do that. But on the other hand, then you have to always do that. That's also kind of silly, isn't it? I don't know. Let's do just print for now. It's a kind of a dump more, but yeah. Okay, so this is just to have information in the case something crashed and oh no, what happened? We'll never be able to reproduce this anymore. But fortunately we have this output, so we can decode with a lot of effort. I don't care what the value was, as long as it's on one line. And I think I'm just going to print the whole thing, let's say between now and let's use square brackets, and it looks more like a board. It's just bullshit. I'm going to use, sorry, I'm going to use this. And again, no new line. But we also have a void board print member function. And that should print something, well, more beautiful. And yeah, I have to think about how that has to look. Does it has to look something like this? That isn't very clear, I think, is it? Surely we have chess pieces. Let's find UTF-8 chess pieces. There they are. And white is black. That's probably because this thing is on. Oh. Yeah. Not sure how that's going to look, but white king is a white king. So I'm gonna use this one. I'm just copy it. I don't know how to work with that. Yeah, it's possible. They don't tell me. I just use it. I mean, my editor, my whole system, everything is UTF-8 on my box. So I can just paste this in a string and it works. Yeah, that doesn't look like a white king, but what can you do? Let's compare this with the other one. I think white and black is reversed. Pretty much. So maybe use a black rook and then call it a white rook. Yeah, because we have inverted. I have an inverted terminal, but which one you want to pick is depending a lot on, well, if you have a black background or a white background then. So let's do both. It'll be nice. And then how do we create... I think this is not even intended to print them on a board, really. Though I think two of these next to each other is more or less square. And let's say it would be shifted, but we could have a king and a space, and that is then the king. And then another king here would be immediately next to it. Well, it doesn't really look like that, does it? So I would rather have something that is twice as big, really. And I don't think they have that, obviously. Nope, they rotated around, but nobody thought of combining 4 characters into a single piece. You say this Seek and Destroy says number 2. I'm very confused because Amon also had the same thing, and then it says I don't know. Did your sentence start with a chess piece? Or with no spaces? Would it nice if I could make this square that reduces distance between these. So print them like this or print them like this? Yeah, I just print them like this, I think. But I still don't have a nice board. I would need the square around this, which is not going to happen, I think. Oh, wait a minute. I have... No. Oh, well, okay. Yeah, well, let's not waste time on it. So it's just a dump. So I'm going to print this, and then if this square is empty, I don't think I really care about the color of the square. Yeah, they changed something. Let me just show you. What? You see, you have something after your name, a little crown. And there's a number 1 and a number 2. Totally new, and I was very confused because the crown looks, of course, like a king or a queen. I think it means top fence, like it says in the top or below end stream. Top fence. You two are my top fence. Determined by God knows what. So they do have chess pieces, but they don't have a square. What is this? Block. Square. Combining enclosing square. That's exactly what you need, except then the king is probably not centered. Oh, well, no, it won't be. I think the king is going to be over here then. There. A squared dot operator. How about a squared nothing? Oh, I have that here. A white square. Oh, a black square and a white square. Ta-da, I found them. But yeah, they do reverse their colors as well. So I want to be able to print a square. I'm just gonna split it up, I think. Like it's a bit lame to use black and white here as well, but okay. So the black looking one is the UTF white. Let's keep black in the up front, which means that I put this on the front, because that is the UTF black thing. Maybe I think I'm gonna make them static stuff. And instead of static, you're supposed to use anonymous namespace these days, as in the last 10 years or so. So let's do that then. I might as well work with U8 strings, maybe. Is there something like an U8 string view? That would be kind of cool. So C++ has an U8 string, I think. Yes, std U8 string. Now, my question is, do we have a string view as well? Looks like yes, but Okay, so now normally I would do something like color equals white. Print empty square, right? So none, white. And otherwise black none. But I want to invert it if this is true. It means that this expression must be inverted. Get kind of an the exclusive OR between this one and the white on black terminal. Well, we can do that in many ways. We can do this thing is unequal to the white on black terminal. But we're going to need that in a few functions, and very intuitive is different. So I think I'm going to call this white with a capital W, and then define that here. Might as well make it a const expression then. First I was thinking, maybe you can determine this as at runtime what it is, but I don't fucking care. Oops. Try to keep black up front everywhere. So first black and then white. Here's two. Yeah, here different. Otherwise, that they don't have the same indentation. I would have to put a knot in front of here. So why not do it like this? But the black here is before white anyway. Okay, so what's next? Print king. No, same thing, but then with the king. Always white. Wait a minute. It's so color is white. Yeah, just white rook. No, I'm confused. Oh, that's the swap happens here. Yeah, of course. But that means I still have to compare it. I was so confused. So is white equals white? Sorry, if white equals black, then so the color is always white. Can we print a black rook? Otherwise you print a white rook. Okay, our board also has a certain size, but my monitor also, let's just not print print something of this size, so maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, yeah, 16. 16 is way enough. Way enough. So I'm gonna print and this then is M, right? M is the vertical distance, so we'll just call this M again. And the top is 0. And we print, and I don't want to hard code anything, so I'm going to use some variable that is defined in board. Although it's not the board is just infinite, so the board will have an internal maximum value, but not necessarily related to the print size. But I probably want to define the actual integer literal close to each other. And that means that the print size should also be defined in the board, I guess. Let's say print M, print limit M or something, or vertical print limit. The other one is then maybe vertical limit, and then you want to have print before or after it. Printing. No. So we need that to be defined inside board. And yeah, that's going to be constant, which can also always be public. And I was going to use 16. And that's an integer. And I make it a const expression, but it's inside the class, so it must be a static const expression. And I'm going to have another one which is called just vertical limit. Let's make that 128 or something. Small enough, I think, to be very fast, hopefully. Although if we can only print 16, maybe I should set it to 16. Otherwise, yeah, let's begin with 16, so we can actually see everything that happens. And I'm going to need the same thing for the horizontal distance. Horizontal. And I'll just use the same value. So now you have all those values together, so you can compare them. Like, oh, I changed this to 256. Why is that still 16? Stuff like that. Yep, and then you have to figure out what it is. Well, it's either an empty square or it is a king or a rook. And I'll just have to, I'm just going to do it the stupid way, which means I'm just for every value I'm going to compare it with the coordinates of all three pieces. Yeah, either that or I have to sort them, obviously. Would be slightly faster, but nah. I think the CPU is going elsewhere than in printing, right? Printing is like not going to happen very often, or I wouldn't be able to follow it. Let's just create a position out of these M&M things. To the current position from M&M. Because that's how the position is done. Okay, by now I do want to have a C tag, so I can just jump around a little bit. I'm going to add an infill source for that. Wait a minute, what do we have at the moment? Nothing. Zero Plus doesn't have an infill source. Wow. No, you don't. I'm just typing this in quickly so I can jump around between my files. Put the cursor on some definition and then jump to the actual definition, I mean. So alias S is going to be defined as I just print everything, I guess, in repo base. What So I need a quick so always fastest if it is copy that from a different project. That's a bit much if you ask me, but okay. Hopefully that works. Still need a build there, no? Not going to change this, just need a build there, right? Put my repo base directly in here. No, but just use repo base then. Repo base / build or something. That puts us, yeah. You don't want to change directory as a result of that, obviously. So after done, we should have done that. What is this? It's not source. Next. Copilot not loaded. What the hell? Oh, because I'm in build. To do a change back. Red is still 0, or maybe I should set red here as well. Okay, that creates a text file, and then we need a different editor, I think, which VR is currently not using any tags. So we am in projects and I go to, well, this one is always the best, is that, which VR or not. Yep. Okay, that should work then. So let's go back to the last thing that I was editing, which was board. No syntax highlighting. Can I jump to it? Well, no highlighting of board anyway. But you can jump to it. I think there's something else needed before I get the colors for the classes, but I won't bore you with that. Okay, so I have M and N are my coordinates of the squares, going from top to bottom and faster from left to right. And we convert that to a position because the position has N first. Why? Oh, because N is actually the horizontal distance. I was confused. If N, well, but the horizontal one must run faster, so it is correct. But N is the first one. Okay, horizontal first, yeah, X is horizontal, isn't it? So it should be NM. I was like, the alphabet is MN, but no. Then, given our position, now this curly braces here means that you use an initializer list initialization. which just works on a struct. Just each element of the initializer list is just applied to the next element. So this copies this n into the n of the position. I don't know why I don't have an underscore here. Probably because it's a struct, or because I forgot it. But there shouldn't be any confusion, because, well, these are members of the of position, and this is just a local variable. So this copies the n to pos n and the m to pos m. And now we forget about the m and n. Now we just work with pos. Now I have to figure out if there is a piece at that position. And we're going to do that in the very stupid way, by comparing the pos with the position of each of the pieces. Let's say the black king again first. Then if the black king, and that is a member of board, right? We are in board member function, so we can have direct access to the members, even to the private members. And the king had the .pos accessor, so we can compare that with pos. Well, we can't, but that's what you want to do. And if that's true, then, then at this point we want to print the king. And it's a black king. And then stuff goes wrong, because I should add a space. I think I'm adding a space in front of it. That should work. And then we have three pieces, so if the white king position equals current position, then print the white, print the king, color white. Else, if the white rook position equals the position, then print the rook. Else print none, that empty space. And the color is then the color of the square, which depends on n and m. And let's say white is in the top left corner. So I'll just do some magic, and then we print black or white. Where the magic depends on m plus n. I want n first now. I don't know why. N plus m. Okay, what magic are we doing here? Modulo 2 equals. So it must print white now if n plus m equals 0. So there must be a 1 then. So now you see that for every square in the inner loop, we do a few tests, possibly. And like I said before, that's absolutely not a problem, because printing is just something you do seldom. Otherwise, my monitor stuff would scroll over the monitor so fast that we can't read it. But if you would want to optimize this, then of course you could, let's say, calculate up front where the next piece is. And so you would have to sort these positions. Just read them all once, and then sort them, so you know which one will be encountered first. Let's say first we would find that one, and then that one, and then that one. And then we would calculate for each of those how many squares need to be printed, or rather how many empty lines first would be printed. And then you could like blit out a whole horizontal line. Maybe, I don't know, just if you have a fixed string, I guess, for, yeah, you could create in advance a fixed string that is a completely empty line. And then blit those out, print those out, and then a partial, and then that one thing, and then the rest, etc. That's a lot of work, and then you get a few milliseconds improvement. And nobody would ever notice it. So that's why I'm not doing it. Yes. It's a slap in your face, Post Bunny. Let me turn it off. Can I turn it off? I don't think I can turn it off. It is nice though that I can see who's here though. No, I can't. There's 8 views and I only see 4 people. I suppose I can only see the people that said something. If you don't say anything, I don't see it. I think it's time to actually print this, which means that a Hello World thingy needs to be done. We need to compile it, which is very boring. Build system. So what I want is to be able to type make, and then it should make it, right? But for that we need a make file. And normally you generate make files. So either I could now set up a CMake file, which then we can use CMake to generate the make file, or I write the make file myself. That is possible, but I have the feeling that writing the CMake stuff is faster even. And certainly if I make all kinds of extensions later on. Yeah, these days you really don't want to write your make files yourself. But that is not C++, of course. I'll try to do it as quick as possible. So in order to create something with CMake, we need a CMake lists.txt file. And that has to be filled with magic again. And I'm just going to copy the magic from my last project. Any project would do, but GitHub. I don't even see GitHub, but it should be there, yes. There's no factorization here. I wanted to go to factorization. Sorry, not factorization, formatter. Where's my formatter? Oh, there's a CW formatter. Guess that's it. Let's steal stuff from here. Okay, we need to set the version of CMake. And at the moment I am at CMake version Wholly 4.02. Ridiculous. I'm just going to set version there. Well, this kind of now forces people to install CMake 4, but I don't think I'll be using that. I'm just copying it from something that already exists. So 3.14 is going to work completely fine. Let's try it like that. Okay, next. Well, why not? Oh, wait a minute. I need to define the project next. So this project is called, I don't care. So I'm gonna call it the same as my directory. This C here, as it keeps confusing me, but it seems that you need C to. If you don't have C, then I think the C is used for is required for certain configuration tests or something. Yep, I'm using C++ 20, so oppa. Debugging. I really like debugging, and I don't know why I'm avoiding it. Now I'm using CMake anyway, but let's for now try to not use my debugging stuff. Of course, we don't use Clang. Okay, let's add a executable. Yeah, how shall I call the executable? That if you run it, and it's going to brute force something. Brute force all positions and how fast you can give mate. I'm gonna call it int chess. It's not really chess. Those are all the source files that we have, and normally you would have to add the headers also somewhere, but if you don't distribute it, that's definitely not a problem. If you leave it away, if you leave that out, so I never add them. Debugging. Include directories. Clang. Yeah, we don't have Clang. Again, Clang. Libraries, we don't have libraries. Subdirectory, we don't have subdirectories. Add executable. It's another executable with its own libraries. I think we're done. I mean, that's what I mean. This is like super fast. So now we already have a build, so now I would run something like the source directory is here and the build directory is there, and then run, and then it generates it. Except that I didn't make an int chess.cxx yet. You need some kind of main, obviously. Yeah, okay. Okay, so I want to be able to run make from anywhere, but if I do which make, and then it's this thing, and that does no change directory. Totally copied it wrong, I think. Or I should just use CMake to build it as well. Let's steal the make from here again. So this says if we have CMake configure options, then if we are using Ninja, then do a Ninja filter with CMake blah blah blah. else, well, I'm not using Ninja at the moment, but we are using CMake, so this is how to build it, apparently. That at least tells it what the build directory is. So I'll just edit my environment, the make file, the make function, I mean, and then use CMake. Now I do need to set a CMake config apparently, because yeah, parallel works, and we can pass a target if you want to. But yeah, I also have to configure it. You have to pass that configuration to CMake. So no, I can't remember all that kind of stuff. So I did this and then something else. I don't know. So what I do is I just always type make, even though it doesn't run make, it runs CMake. I always type configure to configure it and make to make it. And those are then bash functions which do whatever has to be done. Time to also learn something new. So I also need my configure. So sorry, which configure? I'm gonna copy that as well. That works like this apparently. My stupidity for adding this to C++ instead of to projects, because inside the projects directory everything is set up already like that. Why would I start a new project in C++? The function that has to do all the work and I'm just going to copy that again from wherever it is being defined. Does this define configure? Hopefully not. Good. Then this one does. So we go here, from here to there. Configure. Let's just copy everything. And then paste that here. That. And then fix it. Okay, so well, I can use probably everything, but don't need to use everything. So this says if repo base is not set, you have a problem. If builder not set, you have a problem. Builder doesn't exist, it must be created. And then we call set a compiler environment, which I don't have. Might be needed. And then do we have CMake configure options? Yeah. Yeah, I mean, well, it's not really wanting to do that, but it's my way to check if the project is using CMake, and it is. So if CMake configure option is not empty, then we are using CMake, which means that yes, we are using CMake, and all of this can be deleted. And if the Kitash root is not empty, then we're using Kitash, and then LD library path cannot be set. So that's like a fail-safe thingy. But It's not true at the moment anyway, because I'm not using Keytosh and we're not using LD library path either. Then apparently we want to remove the cache file if it exists, and then we run finally the real thing, which is just in the that minus s and that minus b with the builder. And I'm setting some kind of log level, and we are setting the CMake build type to the CMake config, which is the only thing what was really missing. And the CMake configure options are empty because I'm not passing anything, not even going to use it here. So let's just delete everything again. And now I don't have to remember anything. I can just do configure, and then it generates, and I can do make, and then it will compile it. Except that, of course, it doesn't, because I never told CMake to include the current directory. But that should be automatic. I'm very confused. If you don't include with double quotes, it should look in the directory of the current file, aka this is the current file, this is the directory, and that's where position.h exists, or doesn't it? ls/position.h. Oh, it doesn't. How did I call that thing then? Piece still? I don't see. Piece. Okay. Move piece to position.h. That's another downside of not using my normal system. Normally it just stops at after 2 errors. Black does not name a type. Oops. I've got the type here. Okay, nobody can find it even back. Let's just, before I have wasted an hour scrolling upwards. So normally I suppress that with hopefully somewhere in here already, or is it even buried deeper? Doesn't look like it. Is it in here? This is it, yeah. So I need to set more environment variables, namely cflex and cxxlex, which means that cxx must be set, and it isn't, because that happens in the set environment thingy, which I didn't add yet. Or do I have it? Nope, it's not there. Oh yeah, set environment. Set compiler environment. It's this function. Or not. That it should already, cxx should already be set before this. This has to do with installing. I'm not really interested in that, so we can remove that. I think I normally I just set it in env.compiler or something. No, here. So we need this, and then set it there. Top project. Not even sure that exists. Does not exist. Let's use a repo base. I think it's just wrong. This is not a top project. Top project is just 3. And I was so stupid to use. I shouldn't do this either. So we moved one up. Repo base now has twice just 3. And then this must indeed be top project. So I want to move everything one up. Okay, we can do that. Make there just 3. So that's going to be the repository base that I can put into Git. And then I move everything, well, the build directory can stay there, into just 3. Except, of course, the env. My environment should stay here. Plus now the build directory is not correct. It should also be top project. Okay. Hello. Now with learncpp.com or something. Do I say that correctly? Yay, so now it doesn't float as long, or at least it shouldn't. Oh, it's definitely doing that still. It's using Ninja, why? No, it's not, actually. I need to move both outputs so you can see what is being passed to the compiler. And for that I need the compiler options, which I deleted. Making your build system work is a lot of work, usually, as well. Yeah, okay, no viable options from that probably needs a U8 in front of it or something like that. Let's try that. Get rid of this float. So this is a normal string literal with type character const pointer, but U8 yeah, takes char8 type pointers. And I believe that the trick is that you put this in front of it, although I'm not 100% sure. I seldom use this. But hey, now we have an official UTF-8 encoding, if it works. Doesn't seem to work. Okay. Actually, it does work, because now we have a completely different error. It doesn't know what standard cout is here. Oh, okay. These O-stream arrows are always super long. And you always have to start at the top, so I really don't know why it's printing this much. Error, invalid operands to binary expression, O-stream and position. So it doesn't know how to print position. And then it lists every operator for O-streams that it does know, which is a very, very long line. Very long. What is this? Very long list. Just want to know how to print positions. And apparently, including king is not enough. That's strange. I mean, king.h is included. Wait a minute. Resource S, it still works. Officially, I might. Oh no, that works. So we include king.h, which includes position.h. That was the problem, right? Position. And position.h, yeah, it just it doesn't have an operator. Okay, let's add it. Standard O-stream reference operator. Standard O-stream reference op O-stream, comma position. I've had a deja vu feeling though. Did we already do this? But then where? Apparently not. What a mess. What the fuck is this? It's like two things printing at the same time. Colors just in enum. Ah, there's where my deja vu came from. So I did already do this, or not? Okay, I'm a complete idiot. I think I just added that. No, what? Oh yeah, yeah. This is what I added: position, and then I implemented color. I'm a complete idiot, definitely. Okay, for declaration here for the IO stream. Yeah, this is what a bullshit. Oh, it's about position, and I need an IO stream here. Yeah, how do I print positions? Well, that's just a coordinate N and M. Let's just print. Let's print them with parentheses. In M. I probably need to run configure again now. I don't know. Position.cxx, cannot find it. I thought I added it. No, it's called position.cpp. Invalid operands between blah, 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 and basic string view. We cannot print a basic string view. Well, that's new. Ridiculousness. I vaguely remember that it's indeed not possible, and it keeps surprising me because then I forget it again. Let's look print U8 string to OStream C++. How to print an UTF-8 strings? No. Do we print little UFT? Printing with how to print an entire standard format did not support. If Google doesn't work, then we fall back to the AR. How can I print a standard U8 string view to standard cout using C++20? I have favor. Is it? Okay. Yeah, I'll just run into it with the compile error as soon as the bloody OStream stops flooding my error. No, apparently it doesn't think there is a problem. Oh, it uses this. So we have to add a custom, and that is recommended. Why? So again, the overload for the U-string view. No, okay. Where do we define that thing? It's not debug. That should be part of board. That's what I'm using it. Of course, yeah. I thought I was using it everywhere for a moment, but that is BS. Only board is using it, and actually only board.cxx is using it. So before we can print these strings, we do need to define this thing. Better nulls. Just cross. Yay, we have not that many errors anymore. This is undeclared identifier n. It's a member of POS. I'm used to doing this differently. I'm usually adding a member function to position that prints. And then I always use certain magic in headers that then picks that up. So I never have to define this anymore. One of the downsides of doing it like this is indeed that you have to type POS dot in front of everything. And for a very large class, it's so ugly. Plus, then this thing needs access to that, so it must be a friend. In position is a struct, is it? So in this case, we have public access, but yeah, no, it's just the. My method is better. Invalid operand to binary expression. Yeah, like I said, it should work. We want this to work, but it doesn't because we have to define the operator equals for position. Oh, wait a minute, is it struct? Why would that not be defined? Yeah, okay. So we can write it as a member function where you just pass another position, which is done the left hand side is this object and the right hand side is that object. But for an equals, that would be something like this. But yeah, an equals is so symmetrical. It's just a binary operator where if you swap the two arguments and nothing changes. So in general, I just prefer to use a free function. And if this would be a class and you still need access, then you need to make it a friend. So in this case, you don't need to make it a friend. So you can just make it a free function, it's not a member function anymore. And then it has, of course, two, the left-hand side and the right-hand side, two arguments. And no longer a qualifier. But yeah, now it's in a header, so this would be give linker collisions, so make it inline, and then that problem is solved. And if this would be a class and you need that access here, then it must be a friend. So then you have to put this as a friend declaration in here, or you just use the fact that anything defined inside a class is inline by definition. So you can just copy this, put it there, and you don't need inline anymore. I'm still waiting for the missing parentheses that Favor was talking about. Use of undeclared identifier wiki pos. Yeah, that must be a dot. Undeclared identifier print none. Did you mean print king? I call it print empty square. Yeah, well, since I have king, rook, and none as, let's call this none as well. Now it seems to work. Whoa, now we can finally run it. And then I'm lazy, I just want to type this or type it. I mean, it's the easiest way, and that doesn't work. So I add to my print environment, I add to my environment an alias called that, which then does the right thing. So if I type that, I actually want to run the executable that was put into the build directory. Read the environment again, and now we should be able to do this. Yay. And that looks absolutely horrible. Also, of course, we never printed any new line. Okay, where's my board? So we print this is left to right, and then at the end we must print a new line. Actually, we must print a new line and an empty line. So I need to print two character returns. Empty line? No, never mind. Just one. Compile, yeah. Run. Yay, beautiful. Ish. Okay, I want to have the edge as well visible, because the edge is over here. And here the board just continues till infinity and down as well. So let's add a nice edge here and there, and then maybe also draw in the coordinates a little bit. So 0, 1, 2, 3, etc. Well, to do that, we need a horizontal line or something. Let's use Mm. I don't know, line, vertical line, no line. Well, these are lines as well, just not straight lines. Box, that's it, yeah, box line. So let's do box. So at the top, we do this. And then print that. Two of them. Let's see how that looks. No. I guess the first one should go down here or something. I need a vertical line. Looks pretty heavy. Did I use a heavy line or not? Apparently. Okay. Yeah. Okay, coordinates. Maybe tenths is not the right word, but I don't know how to use it otherwise. No. You need two spaces in front of it. Okay, and then yeah, I want the coordinates here as well, I guess. So instead of this, print coordinate. Just also print a modulo 100. Then you can just replace the space in the vertical bar. Oh, I would have to do that for everything. You have a row for every line. Set width to 2. I don't know, what's it called? Set fill. Set fill space. And then it's going to be left or right aligned. Okay, maybe I should use standard format here. Although I don't know how that works either. So I think it's just standard to right or standard left or something like that. We need right, standard right, I don't know. If it compiles, it will work. Yo, manipulators. Unbelievable. Yep, and then the first two lines also need to be indented with 2 spaces. Let's say if it is 2, then we can print the coordinates of the pieces on this line with the other output. So currently no pieces at all, but well. Which is strange, by the way. The while and I mean, there are always 3 pieces. So where are they? Are they at the random positions because I never initialized it? Okay, let's have a look. So board.h simply has these things. Now, for example, I want to see my black king. That means that the king is default constructed the way we do it now. Which means that the position of the king is default constructed. Which means that I'm not sure if that gets a value then. I think they should be both 0. Default construct is, no, maybe not. It's all clear. No, maybe not. Yeah, so they could have random values, in which case they are never equal and therefore never printed. So let's initialize all positions by default. Default constructor. Now, if you do, that's the funny thing, if you don't have a constructor, then it's not initializing it. But I'm pretty sure that if you say the default constructor, or no arguments default constructor, is default, then you would say, well, now it's the exact same thing because it used the default constructor before. No, this default constructor does use brace initialization. I'm pretty sure that now both ints are 0. Let's try it out. That would be funny. Well, you can see that. No matching constructor for initialization of position. That is actually. No, we no longer have this brace initialization, which I need for printing, so I have to add that as well. Oh no, now I need underscores, or it's just going to, no, it's now going to work, right? Damn it, man. Let's call this N1 and M2, M1. Still nothing. Oh, that's strange. Time to run it in the debugger. Well, very random values. So the positions of these things are not initialized with the default constructor. I was kind of sure that it happened, but no. I'm sorry, I gave you wrong information. I need to go to position. So no, we have to explicitly initialize these values with 0 for the default constructor. Hopefully now it works. Yep. So now we have a black king here, but the white king and the rook are also on that place. But it's going by test. So it tests if 0, 0 is equal to the black king position, and it is, therefore it prints a black king. And then the other things are just not printed. So now, yeah, it's time to make a real board, as in set the coordinates. A default constructed board makes no sense, I think. And you just want to always say where the pieces are. You might as well say that for that one special case, and that otherwise would be possible to default construct. So I might as well use a default constructor. If I use a board with a default constructor, and why not? I'm just going to set all the pieces on top of each other. So this now does use the default constructor for all three, which puts them all at 0, 0. But I also want to be able to construct a board from coordinates, which then would be 3 positions, I guess. So for each member, this one, and this one, and this one, you initialize them in the initializer list, which comes after the column there, simply by passing whatever is passed to the constructor. I am not saying that this will compile, but this is what we want. That we can just pass positions and then they will be applied like this. But yeah, that means that you must be able to construct a king from a position and a rook as well. And then how do I know what color is? I don't. We both are kings, so I need to pass the color as well. Let's say the color comes first. Well, let's do it in the same order as we specified here. Position comes first. So the black king is then position, comma, black, and the white king is the position, comma, white, and the white rook is always white. So I'm going to add a constructor now, king, which just simply takes a position and a color. And then again, we just take the first member, which initialize with the first argument, comma, the second member, initialize that with the second element. And then you have to do the same thing for the rook, although that only gets a position. So rook, constructor, position, pos, colon, and then the initialize list is pos underscore comma pos, and then an empty body. Default, what the hell is going on here? It's really printing everything double. Explicitly defaulted default constructor is implicitly deleted because BK has no default constructor. The king has no default constructor. Yeah, so we have to add the default constructor back because that got deleted by adding a constructor at all. And our default constructor, did the right thing, so I can just use whatever the compiler was generating. Calling a private constructor of board. Accidentally forgot to make these constructors public. Okay, that's still everything at 0. And now we can pass 3 positions. And being the human, I want to pass them as coordinates. So just brace initialize each of the positions. And then the first one is the black king, right? So let's put the black king at... yeah, well, I don't really care. Let's see. Let's use this one. Maybe? This one? Let's use this one. Stop. Okay, so that's 4-1. No, this one is here. I don't know if it will work. It does work. Okay. It's not very easy to see, is it? They're very small, very small. Okay, we have a black-looking king. That worked. With 1, 2, 3, 4 squares on that side. And then 1 square in between, and then the white king. Yeah, that's exactly this position. So that's a noise. And then now we set up the basics of all the objects. Now we have to start to work on the actual algorithm. And like I wrote in the description, yeah, we need 2 kinds of ordering. One that orders the board in a way that if the 3 pieces or certainly the 2 kings are in the neighborhood of the corner, the closer they are to the corner, the earlier I want to process them. So in the end, we have an infinite board, and we just find out in how many moves something is made, which is an infinite number of positions. But I want to begin, of course, with both the kings very close to the corner. So maybe kind of like first, if you have just 1 king, you would first do just 0, 0, and then you would do these 2, and then by diagonal. So and you fill it in by drawing these diagonals, and then you go out. And then you can go up till infinity, but if you stop earlier, the most important part has been done. The most important part being everything around in the neighborhood of the corner. But you have 2 kings and a rook. So then what is then close to the corner? And I think that, well, doing these diagonal lines actually means that the sum of the vertical and the horizontal coordinates is equal. So we want to order on, I think, certainly, yeah, good point, Boss Bunny. Do I have food in the fridge? Yeah, I have food in the fridge. So I'm going to write a function that will compare 2 boards and then say this board is smaller than the other board based on the positions of all the 3 pieces. And it must be, reasonable-ish, as in if both kings are very close to the corner, that it definitely must be smaller than when both kings are very far away from the corner. So let's do that. So that's an addition to board.h. Well, this is I can see it, but maybe it's better if we replace these two. With the black is nothing and white is just a dot, a center dot. Let me do that first. Because it's hardly can hardly see what this is. And then, yeah, thank God we have everything in one place. So I think that white should be space. Oh, but now, if white is a space, then that works. So that's space is going to be black on my monitor. But I want to make this one so small that I can still easily see where the pieces are. It must be a really tiny center dot. Is that all we have? It's not very small, I think. It's more clear, right? I mean, you can much faster see where the pieces are. And you can still see where they could be placed. Okay, could also give it a color, of course. Yeah, the only really right thing would be if we had a square, an actual square, which I think I can draw. Of course, you can draw it. I have the box drawing stuff. Could draw a complete grid with the box drawing characters, and then use a color to gray it out, so it's not super white or something. Nah, forget it. Oh, that's. I still didn't print the coordinates here. Let's do that first. So in board.cxx, let's say we are printing this thing, and then at the moment we are just printed m equals 2. Print the board like this. Let's see if that works. Yep. So we see the coordinates of everything. Okay, so I need a function that tells me which board is smaller based on corner, distance. That would be a Boolean, I suppose, where we compare with another board. So. But I don't want to use operator less than, because this is one of the compare functions. We're going to have another one. So let's call this distance something. This is compared with another board. Okay, so we're going to do it like more or less. I think there's a better way, but anything that gives an order, an ordering, as in if two boards are not equal, then one is less than the other. That's and if you swap them, then the other one, of course, I mean, less than. Yeah, so if A is less than B, then then it follows that not B is less than A. That this is what we demand, and of course, if A equals B, then neither of them is true. Then this is false, and that is false. That's what you want. That's actually the only demand. But I think that, well, we know in advance that the position of the black king is going to be pretty important. So let's just compare that. So if the black king dot, and this thing has its own distance compare, why not? Board dot black king. So we just do a distance compare for both of the kings. Distance, let's do less instead of compare. So whatever distance is a bit a vaguely defined thing. If that distance is less for the current object, then this should be returned true. And then we say if the position is not equal, because the black king is not on the same square, and it's deemed to be less than the black king of the other board, then we return true. While if it's the other way around, so the board is distance less our own king, then they are not, well, they are not equal. If they are equal, then this is false and this is false. So they are not equal and it's the other way around. So then we return false. And then if we get here, then yeah, then they must be on the same square. And then I'm going to compare the white king as being more important than the rook. And then lastly, we compare the rook. The position of the rook is a bit of an afterthought. And if none of these 6 comparisons is true, then the position is exactly equal. So that's not less. So that's also false. So that means that we don't have to do this compare. And in fact, you can just return here that last thing. directly. Okay. And then you have to implement this also for the king. Compare two kings. Okay, well, yeah, let's just add the two coordinates, I suppose. So, the sum of the coordinates is more important. But we are only comparing kings of the same color. So really, we just have to compare the position. I can I should just inline this, I suppose. So if the current position is distant less the other king position, then yeah, that's what we want. I don't need this. Do that as an inline thing. The same holds for the rook. Just some inline thing that compares the position. I keep forgetting if I put it below the axis or not. Yeah, below the axis here. Okay, let's keep it a little bit equal. Oops, go to the rook. Other rook. So they use other, the word other or just other rook. It's like they are on the same board. It's not the case. Definitely confusing for the king. I don't know. Let's do this. Okay, now we have then need a distance less to be defined for the position. Which are now used for both the comparing the king as well as the rook, which might be problematic. But in that case, you'll just have to change this one. So what I'm going to write now is should definitely work for the king. So position then has a distance compare with another position, but we're going to think about it for now as the position of a king, where yeah, maybe even the matters if it is a white or black king. No, well, I'm gonna write it for the black king anyway. So I don't know. Well, the whole point was that it works in the sense that if the position is exactly equal, it should return false, and otherwise, yeah, you know, that simple rule, and that's definitely going to be the case. And no matter what I implement. I mean, even if I implement this exact same thing based on position for king, black king, white king, and the rook. Shall I do it inline or not? Nah. Okay, so the position has an n and an m, and the most important thing is n plus m. So we're literally going to pre-calculate it, calling that the sum is n plus m for the current one. And the other sum, now I use other, but whatever, is pos n plus pos m. And then we say that if the sum is less than the other sum, then it is less. Return true. Otherwise, if other sum is less than sum, return false. Otherwise, the sum is equal, but that doesn't mean that the position is equal, so we still have to return something that distinguishes that, and I'm just going to work with, let's say, m. So if m is less than pos m, return true. Okay. I guess next we have to find all the positions that are made. Only after I know in how many moves a position is made, I can do the complete ordering. I would say if a position is made faster than another position, then it comes earlier, it's less than. Only if two positions are made in the same number of moves, then we'll use the distance less. But that means that we need to know if a position is made in so and so many moves. And if I would say generate the positions in the order in already made, and then made in 1, made in 2, etc. That means, let's say I already generated all positions that are made in 0 and all positions that are made in 1 and half of the positions that are made in 2. And then I want to compare two positions where one of the positions is known, that is made in 2, and the other position is not known. Then it is either made in 3 or more, or it is made in 2. It cannot be made in 0 or 1 because I already have those. So if it is also made in 2, we would use the distance less, which is rather arbitrary. So it could be either less or not less than. And if it is not, and I can look at that, so I know what that value is. But say the other position, the unknown, the position for which it is unknown, if it is made in 2 or more, it has a distance that is less than the one that is made in 2. then it doesn't mean that it is actually less, because it could also be made in 3 or 4 or 5. Well, but the larger the mate, more unlikely it is, of course, because the distance more or less grows when the equally grows when the number of moves to mate grows. But I think that the only way to do this, therefore, is if a position does not, if you don't know if a position is made in a certain number of moves, we have to generate all possible moves for that position and look if one of those moves gives us the, well, in this case, made in 1. So we have the position that is made in 2, and we get another position, and then we run over all possible moves of that position, and if well, for the color that who is to move, of course, and if that results in a mate in 1, then it was also a mate in 2, and then we can compare the distance less. And if it does not result in mate in 1, but it results in mate in 2, or we find nothing, it cannot result in mate in 0, of course, because then it would already have been known, because we have all the positions that are made in 1. And so in that case, it is always larger than the other one. So I need, in order to know the ordering, also including the number of moves to mate, I need to be able to do one extra move for whoever's turn it is, and generate all possible moves as such. Okay, this means that okay, whatever. Oh, make this means I need another variable, namely whose turn it is to play. I'm trying to think of a way to generate at the very least the positions, all of them, in a growing distance order. Yeah, that would mean the king, the black king is in the corner. And then the white king cannot be there, or there. So the white king must be, but it can be on this diagonal, which is the closest diagonal. So then the white king must be there or there, which is symmetrical. But I want it to be close to the top as well, as close to the top as possible. So the black king is going to be here and the white king is going to be here as the smallest position. And then the white rook in terms of diagonal could be here. Yes, it cannot be on this diagonal because then it would give check unless black is to move. Yeah, well, I'm not taking who is to move into account yet for the distance. Have to update as well. Who is to move is not that important, I think, for the distance. So, let's put that. Let's put that before or after the rook position. Doesn't really matter, I suppose. If I do put it after, then you can see. Yeah, that doesn't really matter at all, actually. I'm going to put it in front of the rook. So who is to move is more important, and then I want that if black is to move, then that distance is smaller. So we have to update. This is just board. Just do it darkly. I need two compares anyway. So if to play is black and board to play is white, then it's true. So they must be different. Otherwise, if this equal, then we must fall through and let this determine it. Oh, that's not correct. No, I really have to compare them. So if they are different, then who is to play determines the return value. If they're not different, if they're equal, then this determines it. But if they're not equal, then they determine it. And then we return true only if black is to play at that point. So I want to loop over all these positions in an order in exactly the order determined by this function. Then I suppose I have to change the rook continuously without changing anything else. So the rook, we need a rook generator that is based on this and advance that. And if it wraps around, then we need to advance the two play, and if that wraps around, we need to advance the white king, and if that wraps around, we need to advance the black king, and if that wraps around, we're done. Something like that, yeah. So the best approach is again to use some kind of object called iterator. And then we have iterators for all objects again. And then we can put the magic together. So each object is going to have an iterator, which is a class by itself. But let's not create a new file for them. Just put the iterator of the board in board.h. I'm just going to use structs here. Actually, I'm putting it inside the board. And see, I should have made the color a class as well. I made it an enum because, I made it an enum because I didn't see why it had to be a class. But sooner or later, you want to add something for which you need a class. Because it would, it just looks weird, I think. Well, I could just use color here, and that is then who is to play, and then I have to write the code for the color iterator, like right here. Which, why? It makes it less general, a little bit tiny, a little bit more messy. It's not like I'm going to have more than two colors though, but well. I would really like to be able to just write color iterator. No, it is of course not part of the board itself. It's something external. Okay, we need a default constructor for this thing. I suppose that this will do, doesn't it? We also need an end, though. Let's not use the operator plus plus, because then you would have an end. There's not really an end of one quarter infinite board. Just gonna do boolean next or something. Which then returns, let's say, true or false. False, if they couldn't go to the next position because of the vertical limit and the horizontal limit stuff. Now this already works because it's just a default constructor. So literally 3 times. The default constructor, yeah, is just using the default constructor for all members. So we already have it. And then I just call next on that. Okay, but let's maybe first implement the iterators for these 4 before I implement this one. Or often it's not that bad to assume that things that you didn't write yet already work. So we can assume that we already wrote this and that it works, and then implement the next, which then also gives a more clear idea what is needed for these things. Yeah. Let's do that. So I'm gonna have a board iterator next. Which returns a boolean. Okay, and this thing always increments the rook, yeah? So we just do if I forgot how I called it. I just call it white rook. I use the same variable for everything. No, well, I left the lowercase r here. Yeah. So if we call next and it actually advanced, then we're done. So we're gonna do return. Actually, we're done and we succeeded. Now let's say if then, okay, so if we do not succeed, then we just reset this iterator to begin. And then we try the next one, which is to play. And so on. So this works exclusively because this thing is written like that. They're very connected. The ordering is exclusively determined by the black king, like this. Only if the black king is equal, then we look at the white king, and only if the white king is equal, we look at the to play, and only if to play is equal, we look at the rook. Therefore, we can write this like that. Then I need to add an iterator also for all of these classes where the color isn't even a class. Let's start with color. Color now has to be changed into a struct. Yeah, where else did I use color? Let's just add the iterator. Okay, so the default constructor here should be the smallest one, and smallest one was black to play, right? Yeah, that's what I wanted. So let's initialize this thing for the default constructor with black. And then next should, let's do this one inline. I have to toggle it. No, just do it this stupid way. If to play equals black, to play is white, return true. Otherwise, to play is black again, reset, and return false. Yeah, this is again the same for the king and the rook, right? Or and both colors of the king. Just advanced position, which I already did, I think, didn't I? Yeah, that was the something. I have no clue. Grab sources, some. Position. Oh, I did it in distance less, yeah. Okay, but yeah, I'm going to implement the say the rook iterator as running over the position, or isn't it like... I think we just have a position. Or do we have a position iterator? Makes more sense maybe. So the sum is more important. So we want to increment m. We increment m, but if then m, which is becomes equal to board whatever, that is the vertical limit. And let's do it the other way around. As long as after increment it is still less than the limit, then we are done and we can just return a success. Otherwise, m must be reset and we return false. Well, actually, no, not really. The sum must be remain equal. So if m is incremented, then n must be decremented. Hmm. Yeah, that's nonsense. I don't have an n. I just have a sum. So m must stay less than the sum, otherwise n becomes negative. That's the only restriction. And now we have to do also a check on sum itself. Although with a square board, it is not even that easy. But okay. Apart from that, standard min is part of algorithm, I think. Or utils. Oh. Algorithm. Okay. So m is not allowed to be vertical limit. So one past the value that it is allowed, but it is allowed to be equal to sum. So the limit is, let's say, I'm subtracting it from this, 1. So now limit is, it is allowed to become limit. Which means that if m is less than limit, we can just increment it and return true. Otherwise m is reset and sum is incremented, but this gives a possible rise to a cutoff for m. Why this is not easy? Why is it not easy? Damn it. That need to draw a line under 45 degrees needs to be met. Okay, the best vertical line that I can think of is like that. So vertical lines like this represent a line so the sum has the same value. And then horizontally is m. No, vertically is m, sorry. So this is n. And vertically is m. Nothing, right? So if now the horizontal limit is this, and the vertical limit is not even square, but the vertical limit is say, here. So by incrementing m, we run over the diagonal line because the sum is kept constant, like this. And that is allowed while we are here. So going from here to there is not a problem because m is less than the sum. Which means that n is not negative. So if we are on this diagonal and m is less than sum, that means that m is not crossing this vertical line here, the vertical line, at which point n should become negative. So we are clamped here on this vertical line. And the other one is the vertical limit itself, which means this one. So we are clamped on this point here. AKA, there could be a diagonal line like here. So this detects the endpoint, both this point and this point. And the m equals 0 and belongs to a reset. So if we are at the end here and we go to the next diagonal line, then m is reset to 0 because we start at this point. But it's not allowed if we are now beyond the vertical limit. Sorry, beyond the horizontal limit. Aha, okay, so the horizontal limit comes in at that point. So the sum is increased. and then m becomes the standard max, I guess, of something. The standard max of 0 and something that might not be negative anymore if we become too large. That would be then, I guess, some minus the horizontal limit or something like that. Yeah, we need n to become 1 less than the horizontal limit. So if n equals horizontal limit minus 1, and we subtracted that therefore from sum, then we get m. Do it like this, I guess. Yes, so if sum becomes larger than the horizontal limit minus 1, then m can no longer be 0 and it must be larger. So then we follow this line here. Down. And that works until this initial value hits that point. And then and only then we have to return false. Yeah, so that means that the first time that that happens, then m equals vertical limit after doing this mux. Okay, something is wrong because incrementing some here, but I'm comparing it already here with actually what should have been incremented. Okay. Yeah, that should do it. So now we start here and then we do this and then we go here. Plop, plop. For the positions. See if this compiles. Totally not, of course. No match constructor reinitialization of king. Why not? Passing a color type. Oh yeah. Yeah. Mm. Completely unreadable shit. I think no. I think the mess. I would understand the mess better actually, if we were using Ninja, which writes to both standard out and C out at the same time. It is messy, but why would it be using Ninja? Yeah, I think I'm gonna eat food like Boys Bunny said. Let me think. I could spend the next hour fixing my build system, but that is not the point of this stream. Anyways. But yeah, I want to get this to compile, of course, before we stop. I'll just use make J1. Yeah, see, it's not interfering between Cout and Sierra, because if I just run one compile at a time, then strange. Explicitly default. The default constructor is explicitly deleted. King default because color can no longer does no longer have a default constructor. Let's add that back. It's all color's fault. Default constructor is, well, didn't even have a default constructor. I mean, not anything that initialized it with the same value. Use of undeclared identifier board in position. He's .cxx, so that's no problem. We can just include board here. const expression variable cannot have a literal type const color. Because color is not literal, because it is not an aggregate and has no const expression constructors. Totally const expression. No, then why not this one too? And valid operating between color and what? Color and const color. And I thought, let's not use const references because color. Yeah, it's kind of silly. Actually, it's just because we changed the color from an enum into a struct. So now I have to add a function again. To compare two colors. Yeah, I'll call it left-handed side. Right-handed side. Yeah, nothing changed because I don't run it yet, but hey, it compiles now. Well, maybe I should just, you know, iterate over it and then print it. See what happens. Can I construct a default constructed board? Because, yes, I can. But, okay. We can even print it. Really, I want to have an iterator though. Let's make a board iterator. Default constructed iterator should theoretically be etc. And I want to be able to dereference the iterator to a board. So the iterator now must have a board. Const reference operator error. Yeah, or not. Cannot be a reference, of course. We have to actually construct something. No, return constructed. So this is the board iterator. Iterator. Oh, it's a member function of the thing. And a board takes 3 positions in a color, which then of course is the position or sorry, iterator. Do I need the position of the black king? Comma white king, position, comma, white rook, position, comma, to the other way. Wait. To play. No. Yeah, the order is confusing here. Because here the two plays at after the rook. Well, it's more important. To play, just dereference it to whatever. Dereference it. That should construct a board, because that takes color. So then each iterator should dereference to it's in half an hour. It's 9 p.m. so that's a bit early. But I should stop streaming and go eat and maybe watch a movie and stuff, yeah. Definitely going to watch a movie. But it's going. The other iterators also need this and a dereference thingy. This one needs a dereference thingy. The other iterators. Where do I find the other iterators? I didn't add it here. Didn't add it? Yeah, of course I did add it here. And I have a king iterator as well now, but not defined yet. Well, not implemented yet. So we have to construct a king, and the king can be constructed from a pos and a color. Oh, you married in the meantime? It's new to me that you have a husband. I'm watching Netflix. What is the name? The Sandman. That's what I'm watching. Probably going to continue watching The Sandman. It's a bit problematic. I want to create a king, I need a color. So I need to make a duplicate of the color, which is just a fixed color. But if I have a, it's a position iterator, and I don't need a color iterator, just a color. Yeah, I don't know. Most series I don't watch till the end because some point they, in the beginning, they have a good story, and things really happen, and then episode 1 is finished, and it was popular. So yeah, they made a new episode, and then it becomes some kind of drama TV show with nothing happens anymore. It's just about drama between the characters. Boring. Then I stopped watching. But here, there is still something happening because I'm now I'm just at the end of the Vortex thing. So there was a girl that was then the so-called Vortex, and she was ripping apart the whole world, or the dreaming and the real world. So, and there was this serial killer convention with all kinds of new, interesting characters. Yeah. So if it continues like that, then I'll keep watching. But yeah, it must keep you on the edge of the seat, right? You want to see, I want to see the next episode because what is going to happen next? Then it is interesting to continue watching. Yep, so the king iterator advances the position iterator. And that is an iterator, exactly. Boss iterator is an iterator. So but I need a position. So I need to dereference this one. Now it is correct. And then the rook iterator. It's not even defined yet. Oh, well, it is defined here, but the dereference thingy should be a rook operator arrow. I mean, the arrow operator of the rook was not defined. Now it is, and that then I can do that in line, I suppose. So we just construct a rook, and a rook is constructed from just the position, so the dereference of the position iterator. And then the position has an iterator which should still get its dereference thingy. So we have to dereference to a position. Operator star. Oh, this is also pretty trivial. that is sum minus m, comma m. And now I really don't know anymore what I'm missing, so I'll just try to compile, I think. Remember, reference type board is not a pointer. Oh, the stupid thing is, yeah, that doesn't work. Oh boy. Operator arrow must return a pointer, const pointer in this case. Which is problematic, because what is it pointing to then? It's not really an iterator what I have here. Yeah, maybe it is too confusing to use operator arrow and call it iterator, because then it looks like a real iterator, but it's not. I'm just going to rename it to get. Get sounds like you get it and it already exists, but we are constructing it. Okay, what the heck. I'll just use damn it. It's more like create. I'm just going to call it create. Maybe I should just rename the iterator. It's confusing. It looks like an iterator, but totally not. Board. Create board, get board. I don't have to decide. I just call it board. Okay, so everything at 0 and black to play. That would be the first one. Totally agree with that. And then now what happens if you do an increment iterator? That is, I do iterator next before printing it. Then the rook has been moved. Yay. Stuff is moving, but not very clear to see how. The rook is moving diagonally like that. All the way down to 15 even. And then it goes there, which of course is good, because it shouldn't go there. That seems to work then. These have not moved, so the rook is now going to the next diagonal, which should be actually this diagonal, so it should end up there, and that's where it is. Yay. Yep. Go down, down, down. Now, yeah, if this works, then the others work as well, of course, because it's all position. Would be nice though if it was printed a slightly more, you know. So just add a weight. Hope that it looks nicer. Sleep, as it were. Totally forgot how that works. Does it even exist, this? Just go in here and then we just search for it. Example. Thread or chrono? Probably thread, or maybe both. Let's sleep for 100 milliseconds. So magical little operator ms with argument of type unsigned blah blah blah. Where's ms defined then? Oh, we need to do this. How cool is that? Incredibly slow. Now what happened? I'd expected to see the white king by now. Oh no, it switched from black to play to white to play. Yeah. So now it gets to the end, it must be black to play again, and then the white king must be visible. Yep, and black to play. So it totally works. Let's try to speed it up with a factor of 10. Not as nice. Yeah, and so on and so on. So I suppose I have to store all those positions, sort them, and definitely at some point also need to figure out if they are legal positions and if they are mate or not. So illegal must be skipped, and if it is mate, then it's mate. That I need to know that. So can you just do this loop and then skip everything that's illegal, and if it's made in 0, then store it or mark it or something like that. And print it. Hey, maybe just only print it if it is made. Then we get to see something interesting, I think. I am interested in how quickly this finishes if I'm not printing it. Very quickly. Good. Very good. Okay. Yeah, well, get to the interesting stuff now, as in from a programmatic point of view. Suppose that the 8 viewers that I had at some point came here because I had the word beginner's class in it. And that for that, I think it was very educational already, that you saw that I did create a class for everything. We have a class for the board, and we have a class for the king, and we have a class for the rook, and a class for the color. And every class can be printed to an OStream. And yeah, some work into having a nice way to print the board to standard out. A little bit of algorithm stuff, how to write a less than operator basically. But yeah, in terms of making progress with the goal of the program itself, none. But okay, all this work has to be done. before you can even start with that. C++ has a pretty slow how do you call that? You need to do a lot of work before you can get anything or even get to the real stuff. Yep, I guess that next is legal. I just need to know if it is a legal function or not. Well, I don't need to convert. They don't need to construct a board from the iterators, etc. It's probably important in this case to make it fast, so let's add the legal here. And then if we have that, might as well call is legal in next. So just do not return when it is illegal. So skip over all the illegal stuff. Which means that this can be a private function, and then it's only called from next, therefore it doesn't even have to be defined here, really. Yeah. It's basically an internal thing for this next function. So every time I do a return true here, I really have to I should test if it is legal, and if not, then immediately call next again. So suppose we have a possibility to check if it is legal. That should work. So we enter, or we just skip the illegal position, then success is set to false. And it's set to true if either this one or that one or that one or that one is returns true. And after this block it is initialized. So actually no reason to initialize it here. Or I can initialize it to true. And then just not do this. Which means that we only do this if all of those are false. With a Boolean short circuit. Which in turn means that false can only happen inside here, because otherwise, if this is not true, then its success is already true. So I can test success inside here, or I can just also, because if this is not success, we should just return false. So there's no even any reason to set success at all. We can do if this is false, then return false. Which again makes this an end. Oh, we don't need this. So we do. Wait a minute, I need to check if it is legal. Can't do a return false, that's nonsense. I do need a success. But okay, now I don't need the if anymore, because it just means that success must be set to this, the opposite of this value. But hey, that's actually not true, because if success is not true, then we completely failed. It doesn't even matter. There's nothing to test for legal. So here we have if not success, then return false. So yeah, oops. Let's go back to what I had. Okay, so this line now advances to the next position. That is, we move the rook. And if that gives a position at all, if the rook wrapped around, then we switch who is to play. And if that wrapped around to that black is to play again, then we move the white king. And if that wrapped around to, well, the end, got till the end of the board, so we need to move the black king, then we move the black king, and if the black king is also at the end of the board, then we're done. Otherwise, you have a new position, and then I have to check if that is a legal position. And if that is not a legal position, then we just continue doing the same thing. Yep, this is what I needed. So now there's only one place where I have to check if this is a legal position based on the arguments of the iterator, the members of the iterator. Okay, well, it is legal when it is not illegal. So when is it illegal? Let's do illegal then. It's illegal when the kings are next to each other. Or on top of each other, but it shouldn't be possible. Right? Just we only do one move from a legal position. So if the kings are next to each other, then it's illegal, and otherwise it is only illegal, I think, if white is to move and black is in check. Okay, 9 p.m. I'm gonna stop the stream. I'll continue this in the next stream. So when I start coding this again, we'll start from this point. Thank you for keeping me company.